Hey there, I'm SourceMic and welcome to part 9 of the Java series where we are going to talk about generic methods and classes. So as usual, I've got my website open here and it's got all the resources that you would need on this topic, and it's also got videos and code from the previous sections. Again, this is part 9 of a series, so go ahead and click the link below this video if you need to check that out. And while you're down there, go ahead and hit the subscribe button for this YouTube channel. So generic classes and methods. What's the motivation behind this? Well, basically, let's say we are making a class or a method that we want to use in the future, but we don't know the data type that's coming in. Well, normally what we'd have to do is we'd have to create a whole bunch of classes or a whole bunch of methods to cover all these situations. And we'll see an example of the methods in a second. But for example, let's look at our complex data structures that we just went over. And you can see when we made a queue, we have this queue integer queue. So what this basically means is when we made the class, we said, okay, our queue is going to hold integer types. But what would happen if we wanted to make a Boolean queue or a character queue? Well, normally what would have to happen is we'd have to make a whole separate class because all of the variables inside of that class would have to change to compensate to make it be able to work for characters or integers or whatever the type is. But instead of that, we have what's called generics in Java and C# and other programming languages. And basically what generics are is they let you declare a random, basically unnamed type inside of the class or inside of the method so that it can handle that data type no matter what it is. So the queue class, when you look at the class code for the queue, it'll actually be like some blank thing and it'll work for integers or doubles. The same code will work anywhere. And that's really useful because the alternative is to code everything out completely separately for every type of data structure, which is really incomplete, especially when you consider the fact that there might not just be primitive types like ints and doubles, but we might have custom types, like if we had a class that represents people or a class that represents fish or a class that represents bookshelves. Anything like that is going to need its own custom class or custom data structures, and it just gets really messy. The way we do it is by using a generic, and that lets us use any data type regardless. So to handle that, we are going to look at some code, and I've got my Linux virtual machine open. I removed the code from the previous video, the complex data structures, and you can see I uploaded it to Git. Go ahead and find it on Git if you don't want to look on the website. And what we're going to do is we're going to start out by saying we have a bunch of arrays that we need to work with. So I'm just going to copy this because there's like 20 of them. But let's say we have a bunch of arrays. And this is going to start talking about generic methods. Now, let me get rid of some of this space, which shouldn't be here, which is a bit annoying. But we've got an integer array that you can see. We've got a double array that holds a bunch of doubles. We've got this long array that we did not forget the L. You always need to declare the L. We've got a Boolean array. We've got a character array. And we've got a string array. So we've got all these arrays of different data types. And the functionality that we want to do is we want to print whatever's inside the array. So however long the array is, we want to print the stuff that's inside of it to the command line. That's the function we want to make. And obviously this is a really basic example. Maybe you need more complex stuff like sorting or, I don't know, finding the maximum, finding the minimum. But our example is simple. And so to do this, we're going to create a function called void print arrays bad. And basically this function is going to take a bunch of arrays and print it. And again, this is really useful because normally we'd have to write the code a bunch of times, like right here in the main method, like for int array, go through everyone and system.out.println, stuff like that for each one of these arrays. But the way you compensate for that is by making a function, right? A function basically says, okay, if you want to do something a bunch of times, make it a function and you can call the function over again. That's exactly what functions are for, if you remember that video. And we are going to say that we've got a void array, but we're going to say that it's public. And we're also going to say that it's static, which means we don't need to instantiate it. We can just use it. And to print an integer array, what you would need to do is declare integer that this array is going to get passed an integer, and the name of it is going to be an integer array. It's going to be passed an integer array that is named array. And the way you print it is, I talked about this in the data structure video, but not in the for loops video. But a loop basically goes through a number of items, and the way we saw it is like for int I equals 0, I is less than some number, I plus plus. But you can also do this by going through the data structure itself. Java is really helpful. For each integer inside of the array, then that integer that we're on right now is element, and we'll just keep looping through it. So Java will handle that for us, and we want to print it, right? That's the functionality we want. So it's just system.out.println element. Come on, my computer's lagging. Plus space, and I know that there's this extra t here. My computer's lagging, and we'll print out them all on the same line with the space between them, each element in the array. And then we're gonna print. Actually, yeah, we just want them on the same line, not separate lines. And the way we call this is we will say, okay, call print arrays bad on int array. Int array. And we need that closing parenthesis. And it works. So our int array is 0, 2, 4, 6, 8, 10. And it gets past the print array, and print array just goes through each one of the items. It prints the space, and at the end of all that, it prints a new line. And that's exactly what we want to do. But this function only works for integers, which is really not good. Now, the way we could handle this is by overloading it, which is basically copying this. And I'm going to erase this, so don't worry if it looks ugly. And let's say overloading it so that it accepts doubles. And we do another one to accept longs and another one to accept bools. And that'll work, except we'd have to replace this too, right? Because we're iterating through doubles this time, not integers. And we'd have to keep doing that, but that's really inefficient, and that's why we're going to use generics. So what we're going to do is we're going to create a new class to handle this. And we want to be in the habit of doing things in a separate file. So this is also a good opportunity to show why you would use a class. So we're going to say touch array utility .java. And basically what this means is we're creating a class. Oh no, the computer lagged. Touch, not touche. We're creating an array utility, and always when you have a new class, you say that the class is of the file name. The file name is array utility, so that's what we do. We name it that. And we're going to name this public because we want to access it, and my keyboard keeps lagging. And okay, so what do we want to do here? We want to print the array's elements, but we don't know the type that it's going to be. We don't know if it's going to be an integer element or a double element, character element. So what we do is when we create the method void print array, and we got, so this is what we got right now. Right now this would be a print array, and you'd have it as type T. Oh no, I kind of messed that up. Basically, you say that, okay, we've got this public static void print array, and it's got to be a type, right? It's got to be like an integer or a double. And instead of doing that, what you do is right here, you say that this is a generic method, which means you put this T in it, and this T basically says, okay, I don't know what the type is going to be inside of this array. So instead, I'm going to say that inside of this, when I do my work, I'm going to declare this T, and this T could represent, I don't know why I moved that. This T could represent an integer, a double, a person object, who knows. It could represent anything instead of having to be stuck with saying integer or double. And that's how you declare it. So when we're passing the array in, the type is going to be of type T. We don't know if it's integer. It's just, remember, generic is the keyword. It's a generic type, which is why we're using T. By the way, T is not the actual keyword that you need to use as long as you use these brackets. I'm pretty sure you could use L or K or whatever you want, but I like T, so we're going to use T. So we're going to say for T element in array, which is exactly the same as our code from before, we are going to system.out.print, not print line, just print the element plus the space. And we are also going to print a new line, system.out.println, when all of that is done. So again, this is the same code as before with our print arrays bad, except instead of int here and integer here, we've got these generic variables named T, so it can handle doubles or longs or anything. And the function knows to accept it, that it's generic, because we declare this T over here. So let's test it out. I'm just going to copy and paste it because this is a lot. And wow, that was such a weird paste. Oh my gosh, this is a little annoying. I'm not gonna, should I worry about this? Yeah, let's do this. So we're gonna call array utility, and we're gonna call the print array method. And this is a different way of using classes, which is why I wanted to use this example. We did not create a class object like we did in the previous videos. What we're doing is we're saying, okay, since this is static, we don't actually need an object. So that's one reason you would use a static keyword. It's kind of weird, but because it's a static method and it's a public class, actually I don't know if the public class matters, but we're saying that we can just not declare an array utility object. We'll just declare the class itself and call the print array method from it. And we're going to do it for int array, double array, long array, bool array, char array, and string array. And we're going to make it, and everything got printed. This one printed the int array first, and then all of these got printed to the command line because it's generic. The T is generic. Again, that's the generic method. Now, that is good for a method declaration, but what about the class declaration? So again, when we went over the data structures in the array lists, what happened was when we declared them, we had to declare it when we made the class object. Now, I'm going to show you how to do this for classes. So if you want to make your own data structure, which I have a tutorial on for C++, which is really fantastic if you want to learn C++. But for Java, we're going to see how to do it, and it's even easier than C++. A lot easier, actually. So let's say we have a generic class we want to make. The first thing we're going to do is we're going to make the file. So generic class.java is the file we're going to make. I don't know if I'm blocking some of this. So that's great. And we're going to open it up. And notice we didn't even have to change our makefile. Java just automatically knows somehow. Java is magical. So we've got this generic class. And, you know, every time you make a new class, every time you make a new file, I mean, the class name is the file name. And this time, remember, when we declared a stack, we had to declare the type with the actual class declaration. So we're going to use a T again, a brackets T, but we're going to put it next to the class name. So does this make sense? Let's look again at the data structures. When we declared stack, we said stack, the class name, and then the type right then and there. This makes sense. So when we declare the class, we're declaring the type that we're going to be using, which is the type T. Again, so in this case, our stack was an integer, so we put an integer there. When we made a priority queue, we were saying the priority queue class is going to use a string type. Remember, how does priority queue do all this sorting, right? Isn't that a little weird that it could be generic like that and it could know to sort integers or longs or strings? Well, that's because it's using generics. That's why generics is so powerful. So our generic class is going to have this T right here. And then inside of the class now, since we declared the variable when we instantiated the class, we can have some variable named T that's private. And it's of type T, We don't even need to say the t anywhere else. The class knows that because this brackets t is here, that when the class is instantiated, this is going to be an integer or a double, so that it knows that this is going to be an integer or a double because it was declared when the class was declared. That's the whole point. A generic class is when the class is declared, you know what the type is going to be so that you can set these variables up. And we're also going to have another method just to show off a little, named print t, and it's going to accept some t element, which could be an integer, could be a long, could be a person object or something if we had something special. It's going to print that out. Dot print line element. It's going to print it out. And it is also going to set the sum variable, which is of type t, to this element. So again, we're working with generics here. This could be an integer, could be a double, we don't know, but it's going to all work out no matter what, since we declare it when we declare the class. So let's test this out. The way we test this out is we say, come on, work with me. Okay. So we're back to main, and we are going to say, we're going to create a generic class object. And let's create an integer generic class object, and we're going to call it int t. And as usual, the way we declare it is we instantiate it by saying, let's put a generic class object onto the heap, and it's of type integer, and we're going to print it. So we call the int t object, and we call the print t method from it. And let's do it one more time. Copy and paste the code. This time, instead of an integer, let's make it a string. So t in this case is being a string when we initialize it. Again, this new generic class string is coming over to this code and saying, okay, t is a string when I'm creating it. So that means this t right here, this sum variable is of type string. And this t element right here, this is a string too. And yeah, that's how it works. That's why our data structures work. And then we call print on source make. So let's make this and see if it works. We've still got the code from something went wrong. Oh, I forgot to change the variable name. This isn't going to work because we are declaring a string class, and it's trying to print a string, but t is integer. Well, we're saying that the integer class is trying to pass a string, but this is an integer for int t. This is an integer. This is an integer. So you can't call this because t is a string. We're trying to pass a string to an integer, which is what doesn't make sense to it. Oh, I was supposed to fix this too. Copy and pasting is dangerous when you don't pay attention. Something is still wrong? What's wrong now? String t. What did I mess up? What does it say? Int t print 5. Yeah, what's wrong with that? Did I save it? Oh, I don't think I saved it. You gotta save. Oh wait, I did save it. Cannot find symbol print. What am I doing differently here? Did I change something? You guys are probably like, oh, it's so obvious what you messed up. But to me, it's not obvious at all, huh? What is it saying? Error cannot find symbol in t print 5 dot. It can't find the dot symbol. Symbol, error cannot find symbol. Uh-oh. We are having technical difficulties. Let me see if I get rid of these 2 lines if this still works. Wait, did I change something in the Java class? No, I didn't. Let's make this. Oh, it's messed up again. Did I change the print method? Oh, there's no print. There's print t. Okay. That is the issue. I should have just named it print. I don't know why I named it print t. So this should work. Always got to get the method names right. And I'm using like a very basic editor, which is an issue. In the next couple of videos, you'll see that we are going to use a good editor. So 5 got printed and source make got printed. Great. So that's generics. Again, generics are, you want to make functions and classes that work regardless of the data type that gets passed to them. So you don't have to make 20 depending on the data type or object that gets passed to you. All the source code is here, and in the next few videos we'll be going over some more Java stuff. So I'm SourceMake. This was part 9 of the Java series. I'm going to be adding this to GitHub, so if you want the code, go ahead and copy it. Make sure to practice this yourself. That's how you get good at this. And thanks for watching.